Good evening, guys. My name is Vijay. I hope everybody can see the screen. Right. So, so I've been into training for the past 7 years, and I've been dealing with different modules like CCNA, RHC, and currently with VCP. Okay. So CCNA is all about configuration of routers and switches. Okay, so pure network administration. And RHCE program is into Linux administration. And presently, what we are dealing with this course is about VCP. Okay, so which is actually stands for VMware Certified Professional. Okay, so our objective is to cover VCP DCV, data center virtualization. Okay, all right. So let us first introduce what is virtualization, and later, I'll try to show you the difference between physical infrastructure and virtual infrastructure. Okay. So are we good to go? Anybody has any query? You can raise your hand. So I'll start in a minute. Okay, so let us start. So before I talk about what is virtualization, so you can see here, I've prepared a small paint diagram here. So the box, what you see here, uh, assume that it's our data center. Okay. So any data center that you take basically has three major components. Okay. So what you see inside this, the big boxes, what you see here, let us assume they are all servers. Okay. So this is your server infrastructure. So this is your server infrastructure. Okay. And a cloud that you see here with the name Ethernet is actually your networking. All your networking stuff like switches, routers, firewalls are part of this cloud. Okay, this is your network infrastructure, and you have a SAN, storage area network. Most probably it is a fiber channel storage area network, and sometimes you might use a storage system which is IP based, called as iSCSI. Okay, so three major components: one is server, the other network, then you have storage. Now, so let's talk about the drawbacks of this kind of infrastructure. So basically, this is called as a physical infra physical infrastructure. Okay. So how many servers we have here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 100, let us say. Okay. Now all these 100 servers needs to communicate with each other, or probably they need to communicate with internet servers as well, or a public network, or maybe a private network within the what do you call within the site. Now to have communication between the servers, okay, to enable communication between them, so what you need to do, you need to connect the server to the Ethernet with a cable. Okay, so most probably you have a cat cable or twisted pair cable with RJ45 connector. So that cable is connecting your server to Ethernet, and from there it's connected to rest of the servers, so they can interact with each other. And probably it is connected to an external network, like there might be an external network like internet. Okay, so let us assume this is not there, right? So since we have 100 servers, you require 100 Ethernet cables going to a series of switches which are present inside the cloud. Then the critical data that is available on your server, okay, is actually stored on a shared storage or an external storage system called as fiber channel storage system, or some kind of shared storage. So in that case, to gain access to the FC fiber channel network, you need to connect all your servers to the SAN. Okay. So what you see, the cables that you see to the SAN are actually fiber optic cables, and they actually pass through something called as HBA, host bus adapter. HBA, host bus adapter, is a kind of interface. It's a card that you connect to your server. Then the cables which are going to Ethernet are basically connected through something called as NIC. NIC is your network interface card. Okay. So if your server doesn't have a NIC card, or if your server doesn't have a HBA card available, so if it doesn't have, then you need to add a card and make connection from your server to the Ethernet and server to the SAN. Okay. So according to the example what I gave here, there are 100 servers. So obviously you require 100 Ethernet cables and 100 FC cables. Okay. And observe the data center. The external line what you see here is the size of your data center, or the square footage of your data center. And you can observe it's completely packed with servers and routers and switches and your storage system, and there might be a nice SCSI server. Okay. Now, what if you want to add another server to there are 100 servers, you want to bring 101. Is there some space inside the data center so that you can put it? No. Okay. So when you have a situation like this, it's difficult to upgrade the infrastructure. Okay. So let us assume that no, that is not the scenario. Let's say you have enough space inside the data center. So when you are purchasing a new server, you will find some place inside the data center. You put it inside the rack, okay, apply power and install the corresponding software, provide the corresponding network settings and storage settings, and start working with it. Okay. So when you have a scenario like this, so first thing, so what you're going to do, you're going to install an operating system here. operating system. So on the server, you're installing an operating system, maybe Windows operating system or Linux. Okay, server operating system basically. Then on top of this operating system, probably you are running a application. Okay, and one major drawback of this kind of infrastructure is that there is a typical 1:1 relationship between 1:1 relationship between okay hardware okay and app application. Okay, so one hardware, one application. So how many hardwares you have? I mean to say, how many servers you have? 100 servers. So most probably you are running 100 applications. So because of this 1:1 relationship, so the resources what you have here, okay, like maybe network resource or maybe memory that is available on this server or maybe disk or CPU, any kind of resource that you have here is not utilized properly. Okay, so I would say there is around 90% of the 90% resource wastage. Okay, as an example, I'm saying that there is around 90% of resource wastage because you are running only one application. Okay, all right. Then the second drawback, because of the huge number of cables that are that are associated, that are attached with this servers, complexity of the network is increasing. Okay, complexity increased complexity. Okay, so because of this, troubleshooting becomes difficult. Becomes difficult. Okay, then when you want to deploy a new server into the data center, okay, so how much time you take to deploy a new server into the data center? So first you need to talk to a vendor, maybe IBM, HP, or Dell, or some vendor, Cisco. You talk to a vendor and say what you want. The vendor has to build it for you. He has to ship it for you. So once it is available, you have to put it inside the data center. Find some rack space. Once you place it inside the rack, you need to apply power. Okay, you need to install an operating system, you need to install an application, you have to apply all those required patches, provide network settings, provide storage related settings. Once everything is done, you can start using it. So by the time you do all these things, it will be around like 3 to 4 weeks for that new server to be completely functional. Okay, so deploying new server is a headache, so you require a lot of time, so maybe 3 to 4 weeks to deploy a new server. Okay, then since there are 100 servers, okay, um, the amount of power that is required to run these servers and to cool these servers is generally high. So power consumption high power consumption this is another drawback. Okay, then because of any hardware issue or because of any link connectivity problem. Okay, so if there is a hardware issue, the application which is running on the hardware is down. So there is no redundancy for the application. So you have to manually interfere with the server. You either fix it, okay, hardware maintenance you have to do, or bring a new server in place of this. Okay, so hardware failure, hardware failure, application down. Okay, then so those are some drawbacks. The last drawback, when you want to upgrade hardware, let's say the server what you have here has 8 GB RAM. You want to make it 32 GB. Okay, so you have to shut down the server, open the cabinet, and add a new RAM module. Okay, so upgradation of the hardware require downtime. So you have to plan the downtime, bring the server down, add the hardware, okay, then restart the server. So upgrading the hardware live dynamically is not possible, at least for CPU and RAM. Okay, so all these are drawbacks of something called as physical infrastructure. Okay, now let us try to understand the same scenario with virtualization. Okay, so before we go to that, somebody has raised their hand. Mr. Kiran, please tell me.
I'm Mrs. Kiran.
Sorry. Please tell
Yeah,
me.
it's okay. It's okay. So I just want to ask, like, how many servers max we can connect in data center?
It's up to you. No, it's up to your organization, your business. Okay. So depending
Means, is
upon
there is any
no,
limitation in that?
no, there is no
No
limit.
limit.
No limit.
Okay. Thank you, sir.
Right. If anybody has anything else, you can please raise your hand before we proceed to virtualization. All right. So let me minimize this. All right. So now you see the same data center. Okay. So earlier I said there are 100 servers, right? But in this scenario, okay, I have only 10 servers. So server 1, 2, 3, 4, 5, 6, 7, 8, 10th server. Okay. So similarly, all these 10 servers require physical connectivity so that they can communicate with each other. So all these physical servers require connectivity. So let me take a cable, connect it to the Ethernet. Okay. Then since there is a SAN storage system here, probably you're using a HBA card and connecting your server to the SAN. physical connectivity is there. Okay, all right. So now on these 10 servers, so earlier what you have seen, on those 100 servers you have installed an operating system, maybe Windows or Linux, then on top of it you are running a application. But now you will not install any operating system. You take a hardware, you take a server, brand new server, you just apply power, and you are going to install something called as hypervisor. What is it? Hypervisor. Okay, so hypervisor is a software. Okay, it's like a very thin, lightweight operating system. Okay, so you are going to install hypervisor on your server, like you install Windows or Linux. You are going to install hypervisor. Now this hypervisor facilitates creation of virtual machines. Facilitates creation of virtual machines. So on this computer, I mean to say on this server, you're going to create virtual machines now. Okay, so let's say this is server 1, and this is 2, and this is 10. And inside server 1 you have virtual machine 1, 2, let's say 10. Okay, same thing for the rest of the servers. So now tell me how many servers we have. Physically 1, 2, 3, 4, 10, but virtually on each ESXi host you have 10, 10, 10. So 10 into 10 you have total 100 servers. So you have 100 servers. Okay, right. So now this scenario, is it matching with what we have in the previous scenario? Of course it does. So you can see there are 100 servers. Now this is what we call virtual infra structure, virtual infrastructure. Okay, right. So what are the drawbacks of physical? What we have seen, the first drawback, there is a 1:1 relationship between the hardware and the application. One hardware, one application. So because of this, 90% of the resources are wasted. Whereas here, according to this scenario, there is 1:10 relationship. Okay, so one hardware is actually running 10 applications. Okay, so I would say maybe 5 to 10% resource wastage. Okay, that is a first advantage of virtualization. Okay, second advantage, here you have more number of cables, thereby increasing the complexity of the network and increasing the troubleshooting difficulties. But here, how many cables are required for connecting those 10 physical machines? You require 10 cables. How many fiber channel cables you require? 10. So the complexity of the network is drastically reduced. So complexity reduced. Okay, so troubleshooting TS becomes easy. Troubleshooting becomes easy. Then what is the other disadvantage? When you want to deploy new server, it takes 3 to 4 weeks. You want to bring a physical server into the data center. It takes 3 to 4 weeks. Not only that, it will occupy space inside your data center. The square footage of the data center has to be big, more high. Whereas here, if you want a new server, maybe you will add one. That's it. So you have 101 ready. You don't need to purchase it. Okay. You don't have to worry whether there is a space available or not. You don't have to apply power to it. Okay. So all you need to do is provide some connectivity through software. Okay. Do some configuration so that it becomes active. Okay. So deploying a new server, the 101 server what I have just deployed, no, it is just a matter of minutes. Within 10 to 15 minutes, I have a new server available with all required configurations. It has an operating system, it has an application. Okay, no, it's provided with all settings, and it is up and running and also accessible over internet. So you have successfully hosted a server within 10 to 15 minutes. That's the best thing about virtualization. Okay, so you don't need to purchase this hardware also. Whereas when you're in the other scenario, all these 100 servers you need to purchase. You need to spend a lot of money on it. Okay, whereas here you don't need to purchase new hardware. You can create as many number of there is a limit actually, create virtual machines on these machines, physical servers, and proceed with your network settings so that you can host it successfully, right? So what is the other drawback? High power consumption, because there are 100 servers here. Every server will consume power, and you need to install air conditions, ACs inside the data center so that you can cool them, maintain the required temperature. Okay, if it is not properly maintained, you'll have hardware issues. This disk will get corrupted, or the server will hang. Okay, you need to make sure that you deploy required number of air conditions so that you can cool the environment. But here the power consumption is drastically reduced, so you don't need to add more ACs. Then not only that, since the number of servers are reduced, okay, the number of switches that you require inside the Ethernet will also reduce. Probably you are using only one switch here because there are 10 servers, but here, since there are 100 servers, at least you require 4 switches. If you are using at least, I mean to say 24 port switch, if you take, then it require you require 4 switches for providing connectivity between them. Okay, and upgrading the hardware. So the virtual machine what I'm showing here will have virtual hardware. It will have a virtual processor, it will have a virtual RAM, it will have a virtual NIC card. Okay, so let's say the first virtual machine what we have here require one more NIC card, or it require one more RAM module to be added. Maybe it is having a single core processor, you want to add a dual core processor. You can do all these things live, dynamic, without shutting down the virtual machine. That is the best thing about virtualization. Okay, so you can upgrade the hardware of the virtual machine live. Okay, which is not possible in physical infrastructure. Okay, so all these are advantages. Then there is one last thing. When a hardware issue is there, one server is down, one application is down here, right? But here, just try to understand. If one server is down, what will happen to those 10 applications? Because every virtual machine is running application here. There is 1:10 relationship. So if one server fails, and what should happen to those 10 servers? You might be thinking all those 10 servers are down. No, we have concepts where we can cluster, no, host 1, host 2, the server 1, server 2. All these are called as ESXi hosts, which you can put them into a cluster. Okay, so if there is any hardware failure, if the server is down, then automatically those 10 virtual machines which are there will migrate to another ESXi host, another server. Okay, so if a hardware failure is happening, how many servers will go down? None. They will automatically migrate to other host and they will restart there. There is a minimal downtime. There is a small amount of downtime that is attached, but anyhow, you have those servers back running, up and running. Okay, just imagine, if you take the previous scenario, if one server is down, there's no backup or redundancy for the application. It cannot go, it cannot jump and sit on the other server. You have to rebuild this server again. Takes a lot of time. Okay, these are the advantages of virtual infrastructure. Somebody has raised their hand. Let me go to them. Again, it's Mrs. Kiran.
Yeah, sir.
Yes,
So can we add two or more NIC cards to virtual machine?
yes, we can add. We can
Like
add.
if my physical machine is having only one Ethernet card,
Yeah.
then also to one VM, can I add two NIC cards?
Yes. What happens is that uh, inside this server, I'm showing you virtual machines. So
Yeah,
along with the virtual machines, you will have a virtual switch.
yeah. Okay.
Okay. So all your virtual machines are connected to virtual switch like this.
Virtual switch.
Okay.
Right.
So
Yeah.
even if you don't have this cable, okay, the virtual machines are
Mm-hmm.
communicating with each other.
Right.
The physical server may not
True.
be having the NIC card, but the virtual machines have NIC card and they communicate with each other. If you want, you can add more NIC cards to the virtual machine and expand your network, do some networking related configurations. Is that clear?
But if my server is not having a NIC card,
Then
how the
also,
VNIC will be created?
the virtual NIC what you have, okay, is not sharing this resource. When it comes to NIC card, the virtual machines
Hmm.
will share the bandwidth of the NIC, but not the NIC.
Okay. Bandwidth of the NIC. Okay.
See,
Fine.
this cable
Thanks.
what I'm showing you, okay, maybe a
Mm-hmm.
1 Gbps link or 10 Gbps link.
Right.
That 1 Gbps or 10 Gbps is shared among the virtual machines.
All VMs. Hmm.
Okay, but when it comes to
Okay.
connectivity, virtual machine is connected to a virtual switch. That connectivity is,
Hmm.
it doesn't require the NIC card, thing to be available.
Okay.
Anyhow,
And one more thing.
any laptop, even if you take a desktop computer, nowadays it is coming along with a integrated NIC card.
Integrated method,
So
yes.
when we take a server, obviously you can expect minimum of 6 NIC cards on a single server.
Mm-hmm.
Any decent server that you take will have minimum 6 NIC cards.
Six NIC.
Okay, right. So you were saying
Yeah.
something else, right?
One more thing, sir. You told like suppose if my first server fails,
Yes.
then my all VMs will be migrated through clustering, right?
In case if they are in a
To
cluster,
other host.
they will
If
migrate
we'll
to
have a
other.
cluster to other host.
Yes.
So to that host already we are having the 10 VMs. And
Hmm.
all those
You
VMs
should,
are also working.
yes,
That means
you should,
total the 20 VMs will.
yes, you should make sure that you have enough resources, then it will work.
Yeah, that's my
So
point. Oh, yeah,
this,
thanks.
this, this second server what you are seeing, you should make sure that it has enough resources so that it can run 10 plus 10 20.
Yeah, it should have an capability of that
Yes.
sufficient resources. Yeah,
Yes. Generally,
yeah.
a server
Thanks a lot.
will be able to run nearly 1024 virtual machines without any problem. So
Okay,
10 or 20 is not a big deal.
not a big deal.
So somebody else
Okay.
has raised their hand. Let me. Right. So that's regarding virtual infrastructure. Okay. So let's go to our slide. All right. Welcome to VMware. So this is our course content. Maybe you can pause your screen or maybe you can take a screenshot. Okay. So keep this with you so that now you can refer it back every day, so that what we are discussing or what we will discuss tomorrow, you'll get to know. So currently we are at the second the second topic, which is introduction to virtualization. Okay, I'll talk about the course later. What is VCP? What is VCP DCV? Data center virtualization. How many exams you have to write? What is the exam fees? Okay, what is, how you can appear for this exam? What are the trainings that needs to be taken? I'll discuss this maybe sometime later. Okay, maybe at the end of the course, I'll discuss that. All right. So VMware vSphere is based on many components that a vSphere administrator should be familiar with. This module describes the basic concept of virtualization, introduces VMware ESXi and the virtual machine, and shows the fundamental components of vSphere and how vSphere can be used in your data center. Okay, so it's all about VMware vSphere. So in the previous slide, I mean to say in the diagram what I've shown you, I've shown you a hypervisor. I said a hypervisor is a kind of software. It's a software and it's a kind of a very thin layer operating system or a lightweight operating system. Okay, so through which you are facilitating virtual machines. Okay, so when it comes to VMware, that hypervisor is called as ESXi. Okay, so what you see here, ESXi is a hypervisor from VMware. So apart from VMware, there are other virtualization technologies, like you have KVM, you have Microsoft Hyper-V, you have Citrix Zen Server, then there are others. And VMware is considered to be first of its kind and most popular virtualization software. Okay, so learners objectives, what we are going to see now. So you can see what I explained previously, the same thing. Okay, so this is what we call physical infrastructure. We have some servers, we have Ethernet, we have SAN, FC SAN. So servers are connected to Ethernet. So maybe 100 servers are there, 100 cables, 100 servers are there, FC cables, 100 cables. Then you have iSCSI, NFS, other networks. Then every server, at the bottom you can see the hardware, which is called as physical host. So from now onwards, I am going to call it host or ESXi host. Okay, not in physical but in virtual. Then on top of it, you have an operating system. Then the operating system is actually hosting a application, right? The virtualization slide is missing. So this is what happens in virtual infrastructure. So you can see that there's a hardware. On top of it, you have VMware vSphere, which is nothing but ESXi. The hypervisor is nothing but this blue block. What you see is the ESXi, which is actually creating virtual machines. Okay. Now, the advantages being less complexity in network, less troubleshooting, less power consumption. Okay. And the square footage that is required by the data center. You may be having a very small data center and your job is done. And when you want to deploy a new server, it's just a matter of minutes. You are deploying a new virtual machine within 10 to 15 minutes. Okay. So that's regarding virtual infrastructure. So a few more differences. So any hardware that any hardware that you take, maybe physical architecture or when you take a hardware server from IBM or HP or Dell or any kind of Cisco or any other vendor, basically it has four major resources, something called as network, memory, disk, CPU. So also called as NMDC, network, memory, disk and CPU. So all these resources are being used by only one application. But in virtual architecture, the VMware vSphere ESXi will create virtual machines. Every virtual machine will have a virtual hardware. Okay. So this ESXi will fool this operating system. Okay, you're going to install an operating system on the virtual machine. So this operating system will think it is actually running on physical hardware, but this is not physical hardware. It is actually virtual hardware. Okay. So whenever a request comes to the processor, you're running some application. So it requires some CPU cycles. It requires some memory cycles. So when a request comes to processor or any other hardware component here, the processor receives that request and it is going to forward it to the actual hardware. Okay. So depending upon the hardware resources that you have here, so maybe here you have two processors here, but here I'm showing you 1, 2, 3 processors. Okay. So maybe this is quad core processor. This is another quad core processor. So total you have 8 cores. So 8 cores are sufficient to run 8 processors minimum. It might be running more than that also, depending upon the kind of time division multiplexing that you are doing. So all this, I mean to say, the point is the virtual machines are going to share the CPU based upon the time division. So one after the other, they will gain access to the actual hardware and they are going to perform those calculations. So there is a switch. If one processor is using one core here, if the same core is required by another processor, okay, so the switch will happen between one processor to another processor within kind of milliseconds or microseconds. So you will not observe the what do you call the queue or the wait time. So it seems everything is being done concurrently and seamlessly, but the actual hardware is being shared among the virtual machines. So a few more differences between physical machine and virtual machine. Physical machine is difficult to move or copy. You have a physical server, you want to clone it. It's a time consuming process and difficult to do it. And the physical hardware is confined to one particular specific set of hardware. If the physical server is having Intel processor, okay, so you cannot change it. So maybe your motherboard is designed to equip only Intel processor. But in case if it is a virtual machine, now I will use Intel, tomorrow I'll use AMD, doesn't matter. But you need to restart the VM so that you have the new change effective. Okay, so same virtual machine. Yesterday it might be having Intel processor, but today it has AMD processor. Kind of, that transition is also possible. Okay, now so it is not specific to a particular hardware. When it comes to physical hardware, it has short life cycle. Okay, so how many years you can run a physical server? Typically 5 to 6 years. Then you will decommission the server and install a new server, deploy a new server. But when it comes to virtual machine, a virtual machine is basically a set of files, software, pure software. So today you store it on local data store. Tomorrow you store it somewhere else on a SAN store. Okay. So as long as the software is not obsolete, okay, it is not outdated, the virtual machine is always available for you. Okay. So it will have a greater life cycle. Then when you are upgrading the hardware, it requires personal contact. Okay, you have to enter into the data center, open the cabinet, add the hardware or repair the hardware. Okay, so in order to do that, you have to bring down the server. So if you are bringing down the server, there is obviously downtime attached to it. Okay, so your clients, your customers cannot wait, so you will lose business. But here in virtual infrastructure, okay, when you want to upgrade or edit your virtual machine's hardware, you can do it live. Okay, while the virtual machine is running, at the time only you can add hardware. So these are the advantages. And moreover, all your virtual servers are consolidated on a single machine. So this will improve the locality of the virtual machines. Since they are on the same server, the performance is better. The communication between one virtual machine to another virtual machine will improve. So in situations where maybe one VM, no one virtual machine is like your main server. The other virtual machine might be your backup server or some kind of counterpart. So these two virtual machines are working in collaboration and in coordination. Okay, so they are communicating with each other very often. So in such situations, if you are putting them onto the same host, the locality of these virtual machines will improve and you will get better performance. But the same thing you observe here, you have a physical server, you might be having another physical server. They must communicate over a network. They must communicate over a network. This is the server. So these two servers must communicate over network. If this is a slow network, obviously they will communicate slow. So that is a limitation. But here, both VMs are on the same machine. They communicate it live. No live. I mean to say the wire speed. They communicate at the speed of your hardware. Okay, that's one major advantage. All right. Then there's one more advantage. Let's say you are running a e-commerce website, or you're running your business is something related to e-commerce. So like Amazon or Flipkart or Zabong. These companies basically what they do, they sell products online, right? So generally what happens during the month of December, okay, all the servers related to this company, the e-commerce company, or the servers which they are hosting over the internet, or servers through which the payment, especially the payment gateways of these companies, are very busy in the month of December, probably because of New Year and Christmas. Okay, so let's assume during this month, okay, we want our production servers, our payment gateways, to have higher resources in the month of December. They want more CPU, more RAM, okay, for this duration of time. In rest of the months, again from January to November, they must have lesser resources, or the resources what is assigned is not that much required. So is there a way you can dynamically increase and reduce the resource of a physical server? Is it possible? Can you add a processor? Can you add a RAM module dynamically? And when it is not required, can you remove it? Not possible. When you want to upgrade the hardware, you have to bring it down, add the hardware, then again host it. So there is uh, serious downtime attached with that. But with virtualization, you have a concept called as scheduling a task. So you can schedule a task in your virtual architecture or the infrastructure, saying that during the month of December, all my payment gateways, all my production servers should automatically be assigned with more resources. Okay, so once the duration is done, once that period is over, automatically the resources of the virtual machine will reduce. Okay, so that is one a very good feature of virtualization. So because of all these advantages, people are trying to move, and almost every multinational company that you take has, they have already moved their data centers. They have migrated from physical infrastructures to virtual. Okay, right. So here we are talking about CPU virtualization. So you can see there, there are 4 CPUs. Okay, let us say the 4 CPUs what you have here are actually dual core CPUs. This is core 1, this is core 2. Okay, physically how many CPUs you have? Only 4. Physically 4. But according to the number of cores, okay, so total number of cores, every processor that you see here is actually a dual core processor. So total number of cores that you have is 8. Okay, so 4 is the physical CPUs, 8 is the logical CPUs. LOG, logical CPUs. Okay, now if these 4 processors are enabled with something called as HT, hyper-threading, something called as hyper-threading, then every core is divided into 2 cores again. Every core is divided into 2 cores. Now tell me how many number of cores we have total. Earlier it was 8, now it is doubled. So 8 into 2, it has to be 16. Okay, so this 16 CPUs are called as logical CPUs. Okay, so what we are concerned with is logical, not physical. So appearance wise they might be 4 processors, but performance wise it is equal to 16 processors on the motherboard. So all these 16 processors are used by only one application. Just imagine, why would any application require 16 processors? So obviously most of the processors are wasted. But here the same 16 processors, okay, among the 16, 1, 2, 3, 4, 5, 6, 7. The 7 processors are used from the 16. So I can further create virtual machines, add CPUs. Okay. So when I have virtual machines, 1, 2, 3, total 7. Let's say here I have another 4. 1, 2, 3, 4. 7 plus 4 is 11. Another 5, let us say. Okay. Now total number of CPUs that are being used in the virtual infrastructure is 16. So now it is called as balanced. Okay. So all the virtual machines will run without any problem. Now, if you add another virtual machine, okay, adding more CPUs to it, what will happen? Now the virtual machines, all these virtual machines will compete for the resource. Okay, if somebody is idle, they are not doing, then that time is taken by some other virtual processor. So on time division multiplexing, kind of TDM will happen. The terminology is not TDM. Kind of TDM will happen, and they will share the actual 16 cores. All right, so that's regarding CPU virtualization. In the same way, RAM is also shared. Okay, so let's say you have 8 GB RAM here. So 8, 10, 11, 12, 16 GB. Let's say you have 16 GB RAM. Here also you have 16 GB RAM. The entire 16 GB is used by only one application. And here the entire 16 GB is available for the virtual machines. The one is using 8, the other 2, and 1. So 8 plus 2 plus 1, 11 GB is being used. So further 5 GB is available. So maybe you can create one more virtual machine and give 5 GB RAM. Now we call the load is balanced, or there is kind of perfect match. So there is 16 GB and there is 16 GB consumption. Now what will happen when I create a new virtual machine and let us say I am giving 4 GB RAM. Okay. So what is available is 16. What you have assigned is 5 plus 4. Earlier it was 16. 16 plus 4, 20 GB. So 20 GB is what you have assigned. This is called as memory overcommitment or resource overcommitment. Okay, so this is possible, no issues. Your virtual infrastructure will continue to perform. But what will happen is that, so for example, this virtual machine you have assigned 8 GB RAM, but there is a fair chance that you don't use the actual 8 GB. Okay, you might be running an application which is consuming around 4 GB, let us say. Here 2 GB you have assigned, maybe it is using only 1 GB. Let's say this is very much busy, it is using all 1 GB. Here you have 5 GB, maybe it is using 1 GB. Okay, here you have 4 GB, maybe it is using only 1 GB or 2 GB, whatever. Now count the consumption: 1, 1, 4, 6, 7, and 8. Okay, so according to when you view the virtual infrastructure, it looks as if it is consuming 20 GB, but actually not. So the overall consumption is around 8 GB according to this example. So still you can create further more virtual machines, and you can start utilizing this 16 GB of RAM. Okay. So what is assigned is not important factor, but what is being consumed by the virtual machines is important. Okay. So what is being consumed cannot go beyond 16. If it is going beyond 16, then your server will hang, or something. You'll get an error when you try to, let's say you are adding one more virtual machine and you are trying to power it on. So it will immediately saying that not enough resources to power on the virtual machine. Okay. Right. When it comes to networking, we have a very good feature called as virtual switch. Okay. So this is our host. Okay. And remember one thing, in virtual infrastructure, the hardware what you have, the server, is called as host. H-O-S-T, host. And the virtual machine what you have, okay, is actually called as guest. G-U-E-S-T, the guest. Okay, the hardware is called as host. To be specific, it is also called as ESXi host. And the guest might be operating with a Linux operating system, Windows operating system. It might be Solaris or FreeBSD. These are the operating systems that are supported. So what happens is that between the guest operating systems, the connectivity is provided by a virtual switch. And this virtual switch is quite similar to a physical switch or a typical switch that you see normally. Okay, so all the features that are available in physical switch are also available in virtual switch. So this virtual switch can be connected to the NIC card of your host so that you can talk to rest of the world. Okay. Then when it comes to storage, uh, maybe your virtual machine is stored locally on something called as LDS, local data store, something called as local data store, or it may be shared data store. So this is external and it is shared among ESXi 1, ESXi 2. Both are using shared storage. But ESXi 1 has local disk, and here you have local disk 2, some other disk. Okay, so your virtual machine can sit on LDS or can sit on shared data store. Okay, and basically a virtual machine is nothing but a group of files. So those files are stored in a data store, a storage unit, which is formatted with a file system called as VMFS. Okay, so this is a proprietary file system from VMware. But in physical architecture, you have a disk available that is formatted with file system that is native to the operating system. Well, if you are using Windows, probably you are using NTFS. If you are using Linux, probably you are using ext3, something like that. Right. So as I told, a virtual machine is nothing but a set of files. Those files are stored in a folder, and that folder is stored in a data store, which is formatted with VMFS. Right. So regarding virtual machine files, we will discuss in the next class. Okay. So I would like to stop it here. But before stopping, I would like to hear from you. So you can let me know if you have any queries.
अरे ते आपलं हे काय?
Does anyone have any queries? Please raise your hand. Unmute yourself and talk to me. Mrs. Kiran, please tell me.
Yeah, so if I want to share the guest OS to host OS, is it possible?
On host, there is no
Oh,
OS.
sorry.
There is
No,
hypervisor.
sorry. Sorry. If suppose on one VM machine I have installed Windows XP operating system,
Okay.
and my that's my guest operating system,
Mm-hmm.
and the host OS is Windows 7.
Host,
So can I
and
do the
no, that's what I was trying to be specific. This is what you are talking about, right? This is the hardware.
yeah
On top of it, you have hypervisor.
device? Okay.
Okay. Okay. Now
Hmm.
you are calling this hypervisor as a host operating system, right?
Yeah, like suppose on Windows 7 operating system I'm installing the VMware
No, no,
Workstation 10.
no, no. Where is
That's
okay? You're talking about workstation. Let me tell you one thing. Uh,
yeah.
Thanks for reminding me. There are basically two types of hypervisors.
Here talking about the type 1 and type 2 hypervisor.
Right. See there. So there are two types of hypervisors.
Yeah.
Okay. Basically,
Hmm.
you have the hardware. Okay. On top of
Yeah.
this hardware, you are installing a hypervisor. For example,
Right.
ESXi.
ASXI. Yeah.
Okay. Then this ESXi is
Yeah.
creating virtual machines. The OS, what you
Hmm.
see are actually
Okay.
virtual machines,
Guest. Hmm.
guest operating system. Now,
Guest OS.
now the actual hardware doesn't have a conventional
Any
or
other?
a typical operating system what you generally observe.
Okay.
Okay, there's no Windows
Hmm.
Vista or Windows Server 2008 something like that. There's nothing on this hardware. There's only hypervisor ESXi.
Okay. This will be a pure ESXi server, we can say. Hmm.
The ESXi is on the host you have ESXi. On the other type,
Yeah.
type 2, also called as hosted. First, you are
Hmm.
installing an operating system on the hardware. For example, you have a computer at home.
Yeah.
On top of it, you are installing VMware Workstation 10 or 11, whatever.
Right.
Then on
Hmm.
VMware Workstation 10, you are creating, that VMware Workstation 10 is called as hypervisor here.
Yeah. On that we are creating a
On that,
guest
you are
OS.
creating guest,
Guest
guest
OS.
OS, right? This
Yeah.
scenario
Hmm.
adds an extra layer. Now, this operating system, what you see here,
Hmm.
this
Host
operating
OS.
system, okay,
Yeah.
is an extra layer and which is not required.
Okay.
Okay, so when it comes to enterprise level data center virtualization, nobody uses this. Okay,
Okay.
so in real time, when it comes to enterprise level data center virtualization, people go with type 1 hypervisors. Okay.
Yeah.
So you were saying
And
guest OS trying to communicate with sorry, host OS trying to communicate with guest. Yes, that is possible here in type.
that I'm talking about type 2. Huh. In type
That is
2, can I do
available.
that?
Yes, you can do it. But here you don't require it.
Yeah, here we do.
Right.
And one more thing, sir. So what is KVM and like what's the exactly difference between KVM and ESXi hypervisor?
And that's in the next slide here. So
Oh,
I'm trying to move to that. So examples of type 1 hypervisors. So I've been talking about ESXi, right?
right.
So apart from that, you have hypervisor from Oracle VM, which runs on Sun Microsystems or Oracle servers. Then you have Zen server from Citrix. Then
Yes,
you have Hyper-V from Microsoft. These are all type 1 hypervisors. You directly run them on a hardware.
hardware, right.
Then type 2, VMware Workstation, VMware Player, Fusion, Oracle VirtualBox. These are type 2 hypervisors which require an operating system so that you can run them. So
Right.
this is like an application that you install, like you install MS Office or like you install any other application. You have to install these
Hmm.
applications and work with them.
And
Okay.
KVM comes in type 1.
KVM is actually special. It's actually called as a kernel module.
Okay.
Okay. Now
Yeah.
in the previous scenario, what I've shown you here, I'm showing you a hardware. On top of it, you have OS, right?
Right.
If this operating system is Linux operating system, okay,
Hmm. Yeah.
so it's a typical thing, a server with an operating system. Now,
Hmm.
when you install a kernel module called as KVM on Linux, so
Hmm.
this KVM is going to, is going to go and sit with the kernel of this operating system, thereby converting this operating system into a type 1 hypervisor. So this
Okay.
OS will become
Just like a ESXi.
like ESXi it will become. So
Just like.
when you install KVM on Linux, it will convert into a hypervisor. So I would say KVM is type 1 hypervisor in case you mix it with Linux.
Okay.
Same is the case with Beehive. When you mix Beehive with FreeBSD operating system, you get a type 1 hypervisor. So both together type 1. This with Linux is type 1. You can see there.
Okay. And
And
can I add KVM with Windows?
no, it's designed for
No,
Linux.
on Linux.
For Windows, they have designed Hyper-V.
Hyper Microsoft.
Since Windows is from Microsoft, okay,
Yeah. Hmm.
so they don't encourage, somebody, this something not developed by Microsoft,
Yeah.
right?
Yeah. Got it.
So,
Yeah. Thanks a lot.
right. Uh, it seems Sunil has got some doubt, but I don't see Sunil in the list. Sunil, are you there? Okay. So, before I end the session, if anybody has any doubt, please let me know. Unmute yourself, talk to me. Hello.
Hello.
Yes, tell me. You have any doubt?
No, sir.
Okay. Maybe Sridhar, Swaraj, or Twahal. Twaha, sorry. Anybody has any doubt? All right. So Chandra, are you there?
अरे हाँ हाँ हाँ, हाँ। सोनिया बहन के
Chandra, are you there?
हाँ सच कितनी बड़ी चांद थी।
Okay. So thank you guys. You can give your feedback to Spandana or Chandra before we finish. Mrs. Kiran, you have something to say?
Yes, sir. Actually, I missed your first lecture, so can I get the recording of that lecture?
This is the first session.
This is the first session.
Yes.
Okay. Thank you. Yeah. Thanks.
Okay. So see you guys later. I hope you enjoyed being here. Thank you.